Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide for DTC P1AF0, input power A voltage out of range, specifically for the 2023 and newer Honda CR-V models. This DTC indicates an issue with the power supply circuit's voltage within the Powertrain control module, PCM. The PCM is the vehicle's brain, responsible for managing engine performance and emissions by regulating fuel injection and ignition timing. When the voltage falls outside of a specified range, it triggers the DTC, alerting the driver to a potential electrical failure. The connection of a high-voltage battery to the vehicle can exacerbate the situation, so it's crucial to check the standard 12-volt battery supply first. This guide will help you systematically diagnose the problem, starting with an overview of the affected components, which include the PGM-FI Main Relay 1, the PCM, and associated circuits to identify the source of the defect. DTC P1AF0 indicates a voltage issue in the power supply circuit monitored by the Powertrain Control Module, PCM. The PCM oversees various engine functions and requires a stable power input to operate effectively. The primary affected component is the PGM-FI Main Relay 1, which is located in the engine compartment and is essential for supplying power to the fuel injection system. The 12-volt battery serves as the vehicle's primary energy source, and any corrosion or loose connections at its terminals can lead to voltage irregularities, thus triggering this DTC. It's important to check these connections before proceeding with electrical inspections. Additionally, this circuit involves various signals and controls that are crucial for successful engine management. When diagnosing DTC P1AF0, several possible causes should be considered. First, corroded battery terminals can impede the flow of electrical current, leading to voltage discrepancies. Additionally, any looseness in the connections of the battery or grounding cable within the engine compartment can result in similar symptoms. Another crucial component to inspect is the PGM-FI Main Relay 1. If this relay is malfunctioning, it will fail to supply the necessary power to the PCM, causing the voltage to fall outside the specified range. Each of these elements must be closely examined during the diagnostic process to pinpoint the underlying issue. Symptoms associated with DTC P1AF0 can significantly affect vehicle performance. The most immediate indication is the illumination of the check engine light on the dashboard, making it clear that the PCM has detected an abnormality. This could be accompanied by poor engine performance, such as sluggish acceleration or stalling, due to the PCM's compromised ability to manage fuel and ignition systems. Additionally, drivers may experience starting issues, where the engine may crank but fail to start, or may only start intermittently. Recognizing these symptoms promptly can aid in a quicker and more effective diagnosis. The first troubleshooting step involves checking the PGM-FI Main Relay 1. Begin by performing a detailed test on the relay itself to ensure it is functioning properly. It's crucial to inspect the relay for any signs of overheating, damage, or internal faults that could hinder its operation. Additionally, verify that all connections to and from the relay are secure and free of corrosion. Proper function of this relay is essential, as it directly influences the power supply to the PCM and other electronic components in the vehicle. If any issues are discovered during this step, they must be addressed immediately to avoid further complications. The second troubleshooting step requires an inspection of the external circuit, specifically the +B IGP circuit. Begin by checking for any open wires that could disrupt the electrical flow to the PCM. Open wires prevent the relay from functioning as intended and could lead to the DTC being triggered. Following this, it's essential to look for short circuits within the same system. as these can cause excess current to flow, damaging the PCM and other connected components. A systematic approach to inspecting these circuits, using a multimeter to check the resistance, will help in locating any issues that might be present. In this step, you will perform an open wire inspection for the FI Main RLY out circuit. Ensure that you have disconnected the appropriate components before proceeding. Using a multimeter, check for continuity. You should ideally find resistance of less than 1 ohm, confirming that the wire is intact and functioning. Any resistance above this threshold suggests a problem with the circuit. Additionally, pay close attention to ensure there are no disconnections in the circuit that could lead to intermittent failures. If issues are detected, you'll need to trace the wiring back to the source to identify the cause. This step focuses on checking the FI Main RLY out for shorts to ground. Once again, ensure prior components are disconnected to avoid any electrical mishaps. You will need to test the circuit for any shorts that would divert current away from the intended path. Using a multimeter, confirm that the resistance is greater than 1 megaohm. If this level isn't achieved, a short circuit is likely present. Thoroughly inspect the wiring and connectors throughout this section of the vehicle's electrical systems to ensure all components are intact. Any shorts detected will require immediate remediation to restore proper function. In this troubleshooting step, you will inspect the components connected to the FI Main RLY out circuit. Begin by reconnecting the previously disconnected components one by one, monitoring each reconnection for any changes in continuity. This approach helps identify the specific component that may be causing an intermittent failure. During this process, if you notice a return of continuity that wasn't present before, the last component reconnected is likely faulty. It's crucial to maintain an organized inspection procedure to avoid confusion. This methodical approach will ensure that you accurately isolate the problem in the system. Finally, the last troubleshooting step involves inspecting the PCM itself. This step should only be executed after confirming that all preceding components are functioning properly. If all previous tests are normal and the issue persists, the PCM is likely the source of the problem. It's important to note that the PCM is critical for overall vehicle performance and control. Therefore, handling it with care is essential during inspection and testing. Should the PCM be verified as faulty, it will need to be replaced. Follow the appropriate reprogramming steps to ensure compatibility with the vehicle's systems post-replacement. Once all necessary repairs and inspections have been completed, it's time for final verification. Start by clearing the DTC codes from the PCM to reset the system. Afterward, take the vehicle for a test drive to allow the PCM to reevaluate the power supply conditions. Pay careful attention to any returning symptoms that previously indicated a problem. If the vehicle performs smoothly without triggering the check engine light, this confirms that the issue has been resolved. Finally, monitor for any unexpected disruptions over the following days, ensuring the reliability of the repairs made during this process. To prevent issues related to DTC P1AF0 from occurring again, implementing a regular preventive maintenance schedule is crucial. Start by routinely checking the connections on your vehicle's battery to ensure they are clean and secure, free of any corrosion that could impede electrical flow. Additionally, periodically inspecting both the PGM-FI Main Relay and the associated electrical components will help catch potential failures before they impact vehicle performance. Cleaning off any corrosion or dirt buildup around electrical connections can also aid reliability. By adopting these simple maintenance steps into your car care routine, you can mitigate the risk of similar DTCs arising in the future. In conclusion, diagnosing and resolving DTC P1AF0 Input power A voltage out of range involves a systematic approach to troubleshooting. Start with checking critical components such as the PGM-FI Main Relay and the PCM, ensuring that all circuits and connections are in good condition. Each component has an integral role in maintaining the health of your vehicle's electronic systems. Alongside thorough inspections, it's equally important to follow preventive maintenance practices, including regular checks of electrical connections and cleanliness of components. Adopting a proactive stance will help maintain your Honda CR-V's performance and reliability well into the future. Please like and subscribe to the channel. See you next time.